All right, guys, a couple of disclaimers. This class is for beginners, but not idiots. I trust that you can use a search engine to go get the specific details of certain topics. I also have severe undiagnosed ADHD, and that will impact my choice of some strategies. They may or may not work for you, and there's no way for me to know what is and is not the brain poison. In this first part, we will not be even opening Godot. I'm not going to show you how to download Godot. I trust that you can figure that out. So, first things first, what is a program? A program is a series of instructions for the machine so the machine can follow them line by line and execute what you have told it to do. Programming languages are there to help you tell the machine what to do. They are not there to tell the machine to do anything different than any other language. It just makes it easier for the programmer. Now, when you are programming, there are three things that your program can do. It can get data, it can calculate data, and it can set data. The ultimate goal of any program is to set data. Whether this is printing text to the console, or changing the pixels on your screen, or making a big pneumatic hammer go whack, it's all setting data. You're flipping bits, you are sending yes, no charges to things. Whatever the end result is, it is always setting data somewhere. In order to determine what that final answer should be, we calculate data. So we can do math, we can do logic, we can say if this, then that, we can say 5 plus 2 equals, and that can determine whether or not we set the data or what data we set. Sometimes the information we want is just out there, and we want to get it, whether this is through network calls or if it's simply asking another part of the program where it's at right now. And that is getting data. There are lots of ways to do this. We'll talk about them later. Now, this seems really simple, but a lot of programmers lose sight of this. This is your North Star. This is the thing that you will come back to over and over and over when you are lost in your problem-solving adventures. You will have to think to yourself, am I trying to get data, calculate data, or set data? If you try to just wing it, you're going to get lost. And when you get lost, figure out which of these you're doing. It will clarify your program so much. If you separate these steps in your program, it will be much cleaner and easier to maintain. Now, I said earlier that programming languages are for the programmer, and that's because while what you're trying to do is set the color of the pixel on the screen, that's kind of a pain in the butt. There are like 4 interfaces you have to go through, and you have to calculate what you want to set it to and all these things. And that's where all the tools like Godot come in. You want to build a chain of events that is really easy for you to control, a lever you can pull to set that data in the easiest, fastest way possible for you, the programmer. And that's really what a program is you trying to build a chain of things that makes it easy for you to set the data. So that leads us to the next question. What are programs made of? What are the core components of programming, regardless of language? There are roughly 5 to 6 things. Technically, not all languages will use all of these things, but they're all worth understanding for the general topic of programming. The first one is includes or using. This is where you effectively tell the computer to copy-paste code from another file into the start of the file that you're working with. So you could write a whole CSV table in a file and then use #include the name of that file to copy the contents of that into this file. What this lets us do is build libraries of functions that we don't need to necessarily fully understand or know about. I can download somebody else's library of functions, like say OpenGL, and then I can use those functions in my project by including them. And that's all a library is somebody else has written a bunch of code, and you want to use parts of it for its functionality. So anytime you see something like glibc or std, or even things like fetching Google satellite data, it's all libraries that you include, and all that means is that it copy-pastes that code in as though you had written it, so you can use that code. Types and variables seems like a super minor topic, but it's actually kind of the most important thing there is. In most languages, there are a few base types. These are things like integer, float, which is decimal point numbers, char, which is usually the smallest you can get, usually like 4 bytes or something. Bools, which are true or false, and strings, which are words. So the reason that this is important is that memory is set up in kind of these rows of boxes that are all the same size and can hold any number between 0 and 255. So we use those numbers to represent different things. We encode them into different uses. For the letter Y, we might use the number 23. So in box 1, we put the number 23. And that's fine. We put a number for each letter, and then when we're pulling them out, we'll say this number equals that letter. But how do we know how long the word is? And that is why types are important. The important thing to understand here is that each box is going to hold a number. Even if when you pull that out, you interpret that as a letter or a weapon or a model, it's going to be stored as a series of numbers. And so there are a few concerns with storing a series of numbers, the most important being, how long is it? How many numbers are in the sequence before we hit memory for something else? To find the end of a string, we have this kind of null character that says, hey, you're done here. And that's how we know how long a string is. That's fine for things that can be any length and we need to say this is the end of the thing. But numbers usually have a limit. There is a high limit and a low limit. You can only go so negative, you can only go so positive before your number will roll over and overfill the space that has been allotted for it. So when you use something like an unsigned integer, you only get so many boxes to fit that number in. And remember, each box holds a value between 0 and 255. So to represent a number like 1000, we have to do a combination of these bytes to represent that number. And so it gets a little more complicated. Just for fun, let's say that we put the number 1000 in the first 4 boxes. Let's say we get 4 boxes per number on this system, in this language, all that stuff. If we try to read our string YOLO as a number, we're going to get a garbled value, and we're going to miss the terminating character. We're not even going to get the whole thing. If we try to read it as something that gets 8 boxes per value, we're going to have 2 empty or garbled values at the end of our YOLO. And this is really the only point I'm trying to make here, is that variables hold data of types. And the types determine how many boxes you get to fit your values in. And this is critical because when we read them out, we need the exact number of boxes. So if you ever wondered what's the difference between an int and a float and a char and a string, it's how many boxes it gets. And it's very important for when we pull those values out to interpret them effectively, we need to know how many boxes. So that's types in a nutshell. So what are variables? Variables are values that you name, x equals, and then the value that you wanted to store. So if we want to store YOLO, we can do that. Now, GD script, the language that Godot uses, is different from a language like C. In C, you have to be very specific about your types. Godot can infer your types. It can figure out that that's a string, add the extra character, store it all in the correct number of boxes, and interchange it even. You can then say x equals 12, and it will do the conversion itself. However, you have the option to enforce types to match, and I strongly advise you to take it. It will solve so many problems for you ahead of time. So variables are just saying, hey, give me, let's assume that an int is 4 boxes. We're going to give it 4 boxes. So we say int x, you're saying give me 4 boxes, and in those boxes, I will store the value 12. Moving on. We're going to talk about functions. Functions are good. So functions are your bread and butter. Functions are life. Functions are love. Functions take a section of code and they make it reusable. They give it a name so you can call it over and over and over and over without rewriting it. Let's say we have this function add. Add is going to take 2 values, x and y. It's going to create integer z. It's going to set the value of z to the result of x plus y, and it's going to return the value of z. So what this means, all right, so we are going along, and then we want to know how high does the sycamore grow. So we've got var syc height, and that's going to equal add of the current height and the yearly height. Times 50. So when we run this line of code, we establish the variable sycamore height, and we've set it equal to the function add, and the parameters that we throw in, the arguments for x and y, are replaced with the current height and the yearly growth times 50. So those will come in and replace these x and y values. In the function, they'll get set to z equals x plus y. Then we will return the value of z. Now what returning does means that where we put this add call, all of this is replaced by the result of this because it returns z. And that's all a function is. It is some code that you set aside, you give it a name, you tell it what arguments it's going to need to do its work, you tell it what type to return. This says return 4 boxes. It could return a string, it could return a weapon or a model or a level. But you have to tell it what type to return. How many boxes come back? What format is the data? And that is so that the variable can set it up correctly, right? You got to make sure that your variables match. And that's all a function is. So anytime that you're writing a bunch of code and you're like, I keep writing these 5 lines, you want to take those, pull them out, set them up in a function, and then give it a name. This has a couple of advantages. So one, it's just less typing, right? Which is great. But also you can change the logic of this without having to go change every instance of it. If I want to print this value out to the console, I can just add it right here, and that will make every add call print out to the console. It's very powerful. It's very good. Functions can call other functions. Functions can call themselves, but that's kind of an advanced topic called recursion. So just understand for now that a function is a reusable piece of code that you have given a name to. Understand that it takes arguments in order and that it returns a specific number of boxes, a specific type. Okay, if-else control flow is like the simplest thing in the universe. You're not stupid. So I'm only going to explain it briefly. But you can write if condition, so like if x is less than y, print x, else print y. That's it. That's the whole topic of if else. There are some nuances. You can do more. You can do like other if statements before you get to else, but it's just the idea that you can do something if this and otherwise do something else. So for a more relevant example, if the player is on the ground, then he can jump, otherwise he cannot. It's the same principle, just with more words. Loops are fun. Loops are dangerous. Beginner programmers make loops that crash their computers, and it's hilarious. It's very simple to make an infinite loop. There are generally 2 kinds of loops, although there are kind of more these days. But we'll talk about for loops, while loops, and for each loops. For loops, do an action some number of times. You say, do this 8 times, and that is how many times it will do the code inside the loop. While loops continue repeating the code as long as a certain condition is true. So while not on the ground, fall, right? That will be a while loop, just going over and over. For each, we'll iterate over what's called an array. Arrays are blocks of memory that are the same type, put back to back so that they're easy to go from one value to the next without doing fancy computer stuff inside. It's very fast, and it's a good idea for keeping many similar values together. So if I had an array of characters, it would just be one character, and then another character, and then another character. If I had an array of weapons, it would be one block of weapons, another weapon, another weapon. So that means if a weapon is 4 blocks, we're going to have these 4 blocks, then 4 more blocks, and 4 more blocks, and this memory is considered connected. So we can do, like, let's say we have weapons, and there are 5 of them. And what we can do is, for each weapon in the weapons array, do something, like maybe print out the name of it. And what that will do is it will start at weapons 0, and print out the name, and then go to weapons 1, weapons 2, weapons 3. This will be very relevant for games programming specifically because you will be using a lot of arrays to make sure that your game runs fast and that your data is organized. But crap, why does it begin at 0? Okay, so 0 describes the offset from the beginning. If we've set up our boxes this way, and we assume that each weapon is 3 boxes in an array, they're going to be lined up like this. So the first 3 boxes is one weapon, the second 3 boxes is another weapon, and so on. We start at the beginning memory value, right? The address, and then we go forward how many weapons worth of boxes to start reading values. Well, we start at 0, offset, right? This is where the first element of the array is, but it's offset 0 plus 0. After we read that one, we need to go 1 weapon's worth of boxes in to get our next value. It is 1 offset plus 1. And that is why arrays start at 0. This is very important because you are going to be using arrays like crazy, but the main purpose here was loops. So for does it a specific number of times. While does it while a condition is true, such as not on ground. For each does it for each thing in the collection, in this case an array. And that'll make it easy to say I want to do this for each thing in the array. Finally, objects and inheritance is not a concept in every language. However, it is a concept in enough languages and in GDScript that you need to know it. You need to understand it. So we've talked about your base types, your integer, your char, your string, and all that good stuff. But what happens when you want to make your own data type? That is your own specific number of boxes that holds the data that you care about. How can a weapon have a length and a hitbox and a name and fit all that into one variable? The answer is classes and objects. So a class is how you kind of set up your custom code. So you can make the class weapon, and you can say that it's got, let's say, a string for a name. Let's say it's got an integer for length. Okay. So what's going to happen when you make one of these, when you make a weapon, is that it's going to pack your string into so many boxes, and then immediately after, it's going to pack your length into some boxes. So let's say, like, this is the string portion, and this is the int portion. And now when it goes to read out your weapon from memory, it's going to know that it should be a string and then an int and then how many boxes each thing is allocated. And it just jams them all together. When you define the data type, when you write the code for it, that is a class. When you make a specific weapon, that is an object. Objects tend to have both data and functions associated with them. So in addition to these data types, we could add some functions like int getLength and void printName. Now, I haven't talked about void yet. Void is a type for functions primarily that means that it doesn't return a type. It just does something. Like printName. That's not going to return a value of any kind. You're not going to set a variable to it. You're just going to tell this thing to print its name. And that's going to be the end of that. So now we've got this class that is a bundle of data and functions. Now, the cool thing about classes, depending on who you ask, is that they can do what's called inheritance. So what I can do is I can make a new class called sword that is of type weapon. And what I will get is that my sword automatically gets all the stuff that weapon gets. So it already has a name, it already has a length, it already has get length and print name. And then I can add functionality on top of it. I can say my sword also needs to, let's say I also wanted it to be able to get a random hero's name from the lore to say it is this guy's sword. And this is only true of swords. Now my sword can do that as well with string get hero name, in addition to all the things it could already do. Now that we have weapon as a class, as a data type, we can use it just like every other variable. So instead of int, we're going to do weapon x equals weapon, parentheses, means it's a function. Now this is called a constructor. This is only present in some languages, usually ones that focus on objects. What this does is handle the setup of the object. If there's any initial data it needs to calculate, it will also allot the memory for the thing, depending on how big it is, right? It'll set that aside so we know what we're dealing with. I would recommend reading more about constructors and destructors, but it's just not that relevant to what we're doing right this second. Let's say we're just going to print to the console. We could then do x dot name. And that is going to give us the name of the weapon. We can do the same thing if we make a sword. We can print y.name because it inherits everything from its parent class. Okay, so we've got the name, the length. We can do anything with those using that same dot accessor. What we can't do is access x dot get hero name. It only goes one way, parent to child. It does not go child to parent. So weapon doesn't know anything about get hero name. It doesn't know anything about the sword class. The sword class knows about the weapon class. And this is important to keep in mind. When we start going through the documentation, this is how we're going to find out what our objects can do. Now, there's also the concept of slicing. If we treat a sword as a weapon, it should work just fine because the sword is more boxes than the weapon. And let's say we make a new variable, weapon v equals y, the sword y. Now, sword's got extra sword stuff, but everything before the sword stuff is weapon stuff. So it will simply delete this and start treating it as this type. That's very useful to know in some circumstances. You'll probably forget it before we get there, but understand it's a thing that exists. Now, this has been a ton of information, but it is the complete overview of programming. You understand all the parts of the program at this point. There are little nitpicky syntax things that you'll have to learn. You'll have to learn how to write these lines of code. You'll have to learn how to manage variables, how to set up arrays, what kinds of collections you can use to be better than arrays, like lists and things like that, dictionaries. But at this point, you should have a fundamental understanding of programming and all the parts that go into it. You are always getting data, calculating, or setting data. You understand that memory is a series of boxes that hold a value between 0 and 255. And then those values come out and are interpreted by the program to give them meaning. Okay, y could be the same as the color blue. It depends how it's read that determines what it is, really. The number of boxes is based on the type. You understand how it's possible to make your own types and give them functionality. You understand why we start at 0 for index. You understand that if and else is a thing that exists and you can use to control your programs. You understand that functions are their own little named reusable parts of code. You understand return values. You understand parameters. So yes, this was a lot of information, but now you have it. Now, in part 2, when we actually open up Godot, you're not going to be lost. You're going to see the syntax is going to be confusing, but you're going to at least know what we're talking about. And that is why I decided to do this kind of programming primer first, because you need to understand all these concepts before Godot means anything at all. So I'll catch you in the next one.